Hi everyone, my name is Coffey, and what some of you all may not know about me is that I'm on the women's basketball team here at NKU. As a Division I college athlete, I've had to spend countless hours in the gym practicing trying to perfect my game. However, what I failed to consider was just how much my two worlds of basketball and science actually collide. What I've learned is that the basketball itself is a perfect example of thermodynamics. The problem that I've encountered, and that I even got to read about online in an article, was that temperature affects the way the ball bounces. I've found this to be true in my own personal experience, as sometimes when our gym is booked, we're forced to practice in another facility on campus. When this occurs, our managers have to load up all of our equipment and transport it over to the different facility. We practice as normal, and then again, they load everything up, and then they typically store it in one of the manager's vehicles overnight. The issue with this is that basketball is a winter sport, so leaving the balls in the trunk causes them to become very cold. The problem arises the next day when we practice again. We go to dribble the basketballs and they're considerably flatter. As you can see in the clip, there is a very noticeable difference between the way that a cold basketball bounces versus a room temperature or warmer one. From the clip, it's obvious that the cold basketball didn't bounce anywhere near as well as the warmer one. So what exactly is going on, and how is it that a warm basketball magically bounces better than the colder one? Well, physical chemistry can answer these questions. If we treat the basketball as a closed system with constant volume of air within it, then we can use the ideal gas law, PV equals nRT, to explain what is really going on. With this, we would have constant volume, V, moles of gas, N, and our R constant. This would leave us with a direct relationship between our pressure and temperature. The basketball is a good example of thermodynamics because it follows this relationship between pressure and temperature. In the clip we viewed earlier, the warmer basketball had a higher temperature and therefore a higher pressure, which allowed it to bounce better. But the colder basketball had lower temperature and lower pressure, which caused it not to bounce as well.